Hello guys, welcome back. In this part I'll be taking you through how to run our first C program. And I'll try to explain the four processes whenever we are trying to run our C program. So we have the pre-processing part, the core compilation, assembly, and then linking. So let's start. Let's write our first C program. So I'll be using an editor called VI editor. Let us say the name of our file is hello.c. So .c is just an extension for C program. So we have like different type of extension. We have like .txt for for text file, but like for C program we use .c, so vi. So the first thing you want to like write in your C program is stdio dot include hash include stdio dot h. So what you are trying to tell the compiler is that you are telling the compiler to include this stdio header file. So this is standard input and standard output header file. So in this header file you have like declaration for functions that will be using inside this program. So without this header file we won't be able to use the function. So we are telling the compiler to include all these functions. So then so the first the most important function in any C program is int main function. So this is where without this our program won't run. So this is where all the magics happen. So it is possible to like declare some other stuff, probably your class declaration, when we probably your struct declaration. There is no, you can't declare class in C programming, but in C++ you can declare class, but in C programming there is no class. So but you can something like struct and enum, you can declare it outside your main. But the main, it has to be included for your program to be able to run. So we are just going to like print hello world to the terminal. This is the first program for each whenever you are trying to learn any programming language. This is the first thing they will tell you to do. So print hello world. So this printf is actually part of this stdio.h. It is declared in this stdio.h. So if you don't include this, we won't be able to like use this in our program, right? So let us try and run the program. So then I said there are like 4 steps in whenever we are trying to run a C program. So the first step is actually we said it is what we call it preprocessing. So gcc minus e then we can say hello, the name of our program. Then we can put it to, let me say hello, we can say hello p.c. So what this is trying to say is that actually this preprocessing, if we do gcc minus z hello.c, what is going to happen is that the output will be in the standard will be in the screen, which the screen is actually the standard output. So we have to like redirect the output into hello.p.c. So if we don't redirect it, it is going to like print we are going to like be seeing all the everything inside in our screen, sorry. So if you click on enter, so and if you want to like know what kind of file is this lop.c, so this lop.c is actually a source file. So file hello, so this also is also hello.c is a source file, lop.c is a source file. The only difference between both of them is that hello.c, which is the original file, is actually has something like hash include, but in lop.c, so the I explained that the hash include is going to include the standard input and output declaration. So this minus gcc minus z has already like tell the compiler, okay, include, preprocess it, include the standard output and input file. So in this lop.c, so the standard input and output file has already been included. It has been included, so we call it preprocessing. So another thing that happened during the preprocessing is that it's going to remove any comment if you have any comment in our C program. So if you have, but right now if you look at our C program, we don't have any comments, right? So that is that. So then let us try and see our lop.c, and so this is our lop.c. This is like the small program that we actually write turn into this. So let me just clear this. So that's lop.c. The command that I use is cat lo.lop.c. So this is just going to like show the command. This is going to show the file in the standard output. So the first stage was what preprocessing. So the second stage is what compilation. So during the preprocessing, so the compiler include all anything that we included, probably hash include. It's going to like remove the comment also. It's going to There's also some other things that it is going to like do. So then after that we have the second stage, which is what core compilation. So for core compilation we use gcc minus x. So gcc minus s dot lop.c. So our file already like changed from lo.lop.c. So during this gcc minus s lop.c, what is going to happen is that our compiler, so it is going to actually like convert this lop.c into an assembly code. It's going to compile it into it's going to change it into an assembly code. So and then the assembly code is going to be in form of file lop.s. It's going to be lop.s. So you can see, so what this gcc minus s lop.c actually did was to like convert the code into assembly language. So and it's going to change this lop.c. It's going to change it to what lop.s. And the thing is that lop.c and it won't be deleted. It will also be present in our folder. So let us like list all the file in the folder. So this is luckily this is lo.c will also be present, lop.c, and this is what lop.s. So let us check lop.s again. So this is what assembler source. So this is like assembly language. So if you cut it on your screen, you are going to be seeing jargons. No, this is sorry l.s. So you can still like read it. So this is just like assembly language. Actually, this is assembly language. So then the next step is the first step was preprocessing. The second step was core compilation. So the third step is now what is assembling. So during this process, what is going to happen is that the compiler is going to convert the what assembly code. It's going to convert it to machine code. Don't forget, I told you in the previous part that machine code is the only code that your computer can actually understand. So but it is very easy for the computer to actually like convert the assembly language to machine code. So we can actually like do that using gcc minus c. So what is lop.s, sorry. So whenever we do this, so this is going to create a file called lop.o. So that lop.o is actually an object file. That object file is also known as what machine code. So object code, machine code, they are the same thing. So let us see if we can say lop.o. So we can see, so this is relocatable. So elf, this is what object file. Actually this is object file and it is like machine file. If you try to like cut it in your command cut it to see what is happening, I think you'll be seeing jargons. So you can't you might not be able to understand all this. So that's that. So let us clear. So you might want to like see this. So this is lop.o. This is the current state that we are in, from lo.c to lop.c, then to from lo.c to lop.s to lo.c to lop.c, then to lop.o, then to no, that is a mistake. So it is actually from lo.c to lop.c, then to lop.s, then to lop.o. So this is like from lo.c. During the processing we change it to lop.c, and then after that we do the core compilation to lop.s. Then after that we do the assembly to lop.o, which is an object file. So the last stage is actually like linking. So we can so if you are going to like link it, so linking is actually going to like automatically happen whenever you because at this point when it is lop.o, it is not executable. We can't like execute it to see what we wrote. We can't. Uh it is not executable. So if you want to like make it executable, gcc minus o, then we do probably lo, then lo, name of the current file lop.o, lop.o. So then whenever we click enter, so then there is a file called lo. Yeah, so let us try and check file lo that has been created. Like this step actually created the file lo. So and if you see, this is what you see, something like what executable. So definitely this lo file is actually executable. So if you try to like execute it, so you can execute it by doing this dot slash lo. So and you see that what the lo word that we actually like put in the first file in the lo.c, let us see vi lo.c. So this is actually the lo word. So let us clear this. So the first step was actually pre-processing. Let me vi. So the first was pre-processing. During the processing, we don't forget we use gcc minus e to gcc minus e, the name of the file lo.c, then we cut it, we redirect it to lop.c. So the next stage was called compilation. We use gcc what gcc minus s, capital S, lop.c. So the next stage was gcc minus c lop.s. You know how like after this stage gcc minus s lop.c, what will actually happen is going to like this command is going to like change this lop.c into assembly code, which is lop.s. So then the next stage will be gcc minus o lo and lop.o. So these are the first stages whenever we are trying to like compile our C program. But you'll be like, so do we have to go through all this process whenever we want to compile any C program? No, you don't have to go through any of this process. So you just have to like go through just one process. So and the thing I forgot to tell you was that during the linking, so this stage is not actually for linking. So this stage is actually like we are just trying to like change this object file to executable file. So but during this process linking also happened. So linking is that what happened during linking is that we have like in most of the like a very large program, what happened is that there are like many object files. So this linking is going to like link all those object files together. So that is just what it's going to do. So I was talking about that we don't have to like go through all this process whenever we are trying to like compile our C program. So you have like file lo.c. So what we can actually do is just do gcc minus o, the last stage, just go through the last stage, minus o lop, let us call it lop, so lo.c. So directly we don't need to go through all the process. So if you do this and we just run our lop the way we run our lo, and we can see our lo word. What actually happened is that this command is very sensitive. So without going through all the other process, if you just type this, so this is just the other process will actually like happen, but it will be like internal. We won't be able to like see it. So this is just going to like convert this directly into what into the into executable file. So though all other processes also happen, but we won't be able to like see it, and it is not going to like create any other file for it, so it's just going to like convert this directly to this. So instead of going through all those process, so it's going to like do it directly, and keep it's going to like keep it hidden from us. But the reason why we actually like go through the four process is actually just to, like explain to you the those four processes. So I think that is all that you need to know so about like compiling C program.